Assalamu alaikum students, my name is Hassan. By the grace of Allah Almighty, we have covered more than 4 chapters of class 9, first and second chapter of class first year. This is about physics, and when we are talking about the mathematics, we have covered more than 5 to 6 chapters of class 9th. Similarly, more than 2 chapters of class 10th and first year and second year. This could be possible by the grace of Allah Almighty that we are working in a very sensible institute which is called the Professional Academy Texla. In this online series, today we are going to solve chapter number 1 numerical of class 10th physics, which is called simple harmonic motion, or in short form this is called SHM. As we have discussed before that when we are going to solve the numerical of a chapter, we must have to learn and understand the formulas which have been discussed before in the chapter. So when we are discussing about the simple harmonic motion, then the basic formulas are going to be solved and discussed in this lecture also. So pick up your pen and pencil and start the solution of this chapter. Bismillah ar-Rahman ar-Rahim. Numerical problem of this chapter are consisted about, I think so, 10 to 12 words. So the first part, I'm going to read it. The time period of a simple pendulum is 2 seconds. What will be its length on Earth? What will be its length on the moon if gravity of moon is equal to GE divided by 6, where GE is equal to 10 meter per second square. So first of all, we have to write about the data of this numerical 10.1 data. As we have some given data, so the time period of a simple pendulum is 2 seconds. Firstly, we are going to write time period which is 2 seconds. What will be its length on Earth? This is a portion which is to be found. What is its length on Earth? We are going to denote length on Earth as LE and length on Moon as LM. Similarly, GE, gravity on Earth is given, GE is equal to, as we also know that, 10 meter per second square. As GM is given as GE divided by 6, so its value will be 10 divided by 6 will be equal to 1.67 meter per second square. So this is the complete formula. We are going about solve this numerical. So we have started solution. As the formula for time period of this situation is t is equal to 2 pi under root L over G. So we can't solve the direct formula because the length of this pendulum is taken in the under root of this formula. So first of all, we have to reduce or remove this under root as we are going to find the value of length. So taking square root on both sides, t square will be equal to 4 pi square L over G. So L will be equal to, the formula of L will be equal to G t square over 4 pi. I am going to denote this equation as equation number 1. So firstly, we will find the length of this pendulum on Earth. So LE will be equal to GE into t square divided by 4 pi. GE value is 10, t square is equal to 2 square and 4 into 4 pi square and 4 into 3.14 square. When we solve it, we will find 10 multiplied by 4 divided by 4 multiplied by 9.8. 4 will be cancelled with 4. So 10 divided by 9.8 is equal to LE is equal to 1.02 meter. This is the length of pendulum at Earth. No, for Moon is equal to LM is equal to GM T square divided by 4 pi square. So GM will be equal to, as we are going to pick this value from the data, which is about 1.67. So 1.67 multiplied by T square is equal to 2 square divided by 4 into 3.14 whole square. So this will be equal to 1.67 into 4 divided by 4 multiplied by 9.8, and the solution will be LM, the length of this pendulum on Moon will be 0.17 meter. This formula is very important. This will be again used in the coming formulas, coming numericals. So we are going to repeat it. T square is equal to 4 pi square L over G. T square is equal to 4 pi square L over G. So this is the solution for the first numerical of this chapter. So when we now we are going to solve the second numerical of this chapter, which is about I think so gravity also. So numerical number 10.2. The pendulum of a length data given. Length of a pendulum is 0.99 meter. Taken to the moon by an astronaut, the period of the pendulum is 4.9 seconds. T is equal to 4.9 seconds. What is the value of G on the surface of the moon? This is the counter numerical for the first numerical. In this numerical, we are going to find GM. If we are going to copycat the value of G from the previous one, then we just have to write the value of GM is equal to 1.67 meter per second square, but we are going to solve it. So the formula, as we discussed before, that T square is equal to 4 pi square L over G. So in solution, firstly we will write the formula is equal to 4 pi square L over G, because we have to find the value of G. So we will put it on the other end. G is equal to 4 pi square L over T square. Okay ji. So by putting the values from given portion of the data, we will find G is equal to 4 into 3.14 whole square 0.99 divided by 4.9 square. So the value of G will be, if we solve it, so 4 into 9.8 will be 39.5 multiplied by, the next value will be 0.99 divided by, the answer of the square of 4.9 is 24.01. So this answer will be 39.5 multiplied by 0.042. So the value of G will be 1.65 meter per second square. So this is the final formula, final result of the second numerical of this chapter. So the third question will be, find the time period of the simple pendulum of 1 meter length placed on Earth and Moon. The value of G on the surface of Moon is 1/6 of value of Earth, where GE is equal to 10.5 meter per second. In third numerical of this portion, we have to find the time period of a pendulum which is placed firstly at the surface of the Earth and then on the surface of the Moon. The value of G is also defined and can be calculated from the given portion of the data. So V is equal to F lambda. F is 5 and lambda is equal to 0.06 and the answer will be 0.3 meter per second. This is the solution for numerical number 10.5. 10.6. A wooden bar vibrating into the water surface in a ripple tank has a frequency 12 Hz. The resulting wave has a wavelength of 3 cm. What is the speed of the wave? You just have to put frequency is equal to 12 and lambda is equal to 3 cm, which will be again divided by 100 and we will obtain we have the value of frequency is equal to 12 and we will obtain here 0.03 and the answer will be 0.36 meter per second. So this is the smallest portion for the solution of 10.6. I am not going to solve 10.7 and 10.8 because these are very lengthy and in parts, but also very easy to solve. But we are about to solve 10.9 and 10.10. So I'm going to read the statement for the numerical 10.9. At one end of a ripple tank 80 centimeter across, a 5 Hz vibrator produces wave whose wavelength is 40 millimeter. Find the time and the waves need to cross the tank. So in this numerical, the given portion of the data can be written as length of ripple tank is given as 80 centimeter, which is about 0.8 meter. This is the length of ripple tank. A 5 Hz vibrator. We have frequency 5 Hz. Produces wave whose wavelength is 40 millimeter. Hence lambda is equal to 40 millimeter, and if we change it, it will be converted into 0.04 meter. We have to find the time taken by the waves to end the portion for this ripple tank. So firstly we have V is equal to F lambda. So V is equal to F 5 Hz and lambda is equal to 0.04. In this situation, answer will be 0.2 meter per second. Now, as we have distance formula, S is equal to Vt. So T will be equal to S, we have 0.8 and V is equal to 0.4. So time will be equal to 0.2 4 seconds. This is the solution for numerical 10.9. Now we are going to solve the last numerical of this chapter. What is the wavelength of the radio? 10.10 data. What is the wavelength of the radio waves transmitted by an FM station at 90 megahertz? This is the frequency, 90 megahertz, which is about 90 into 10 raised to power 6 hertz. The next one is, and the speed of a radio wave is 3 into 10 raised to power 8 meter per second. V is equal to 3 into 10 raised to power 8 meter per second, and you have to find the lambda. So V is equal to F lambda, and lambda will be equal to V over F. So we just have to put the values for these variables. As lambda is equal to V over F, so we have the value of V into 3 into 10 raised to power 8 and 90 into 10 raised to power 6. And as we have the same basis, so 10 raised to power 8 minus 6 divided by 30, which is equal to 10 raised to power 2 divided by 30. So it will be equal to 100 divided by 30, which will be equal to 3.33 meter. So lambda will be equal to 3.33 meter. So this is the last numerical of chapter number 1. I hope so you have truly understand the basic nature of these numerical. I think so this will be very helpful for you. Inshallah, we will start the next chapter in the coming days. You have to revise these numerical because a very important portion of the federal board paper and Punjab textbook board paper, or the boards which are associated with Sargodha and somewhere else, a very important portion of these numerical is taken every year by the students in a wrong way, because they are not trying to fully understand the nature of these numerical. So wish you very best of luck to solve these numericals. Take care of yourself. Thank you so much. Assalamu alaikum.